In 1a, we're removing absolute values, and we have a less than symbol, so the absolute values are removed in the following way. Minus 3x plus 2 is between 7 and minus 7. And we solve this isolating the x. Let's subtract minus 2 from 3 sides, and we have minus 3x. And here we have 5, and here we have minus 9, and then just divide by minus 3. Of course, we have to change the direction of the inequality when dividing by negative. And we should also write this forwards. We put the smaller number on the left and the larger on the right, and make sure it reads the same way. This says x greater than minus 5/3 and x less than 3. In B, we have a greater than, so this opens as follows. We say 5x plus 1 greater than 7, or 5x plus 1 less than negative 7. And just solve these. We have 5x greater than 6, x greater than 6 over 5, or 5x less than minus 8, or x less than minus 8 over 5. In C, we have something in absolute value equal to a negative, so this isn't possible, so we say no solution. And let's look at D. We have two inequalities with an or in between, so we're going to solve each one separately. So here we have 2x less than 6, x less than 3, and here we have x greater than 9, x less than 3, or x greater than 9. So here's x less than 3. To the left. And x greater than 9 is this piece. So the combination is both together. If we put them together, we have everything to the left of 3 and everything to the right of 9. And that's what we do for an or. We combine the two. Okay, let's look at E. For E, we're going to isolate the absolute value on one side. And now we'll open up absolute value. We'll say either 2x plus 3 is equal to negative 10x, or 2x plus 3 is equal to the negative of negative 10x, which would be positive 10x. And solve each separately. So here, let's say we subtract 2x from both sides. So we have minus 12x equals 3, or x equals 3 divided by minus 12. And here we have 8x equal to 3, or x equals 3 over 8. And we always have to check in the situation where we have absolute value on one side and something with x's on the other side, we must check each answer. So let's do our check. Substitute in minus 1/4, and here we're going to substitute right here. Minus 2 over 4, that's minus 1/2 plus 3. Minus 10 over 4 equal 0. Here, 3 is equal to 6 over 2. And let's write this as 5/2. Okay, we want to see is this equal to 0? Okay, so here we do have the absolute value of 5/2 minus 5/2, which is equal to 0. So this is valid. Let's check 3/8. Substituting into here, 2 times 3/8, that would be 6/8, plus 3. Is that equal to substituting 3/8 into here, minus 30 over 8? Well, this side is positive, this side is negative. So this is not a valid solution, and negative 1/4 is the only solution. And let's do one more at f, like this. And so we want to isolate the absolute value on one side, and now we're ready to open up. Either it's equal to x or equal to negative x, and solve. Subtract 3x. So here we have x is equal to negative 1. Here subtract 3x. And we have x is equal to minus 2 over 4, or negative 1/2. Okay, so here we have to, again, this is a situation where we have to check when we have absolute value on one side and something with x's on the other side. So here we have the absolute value of minus 1 equal to minus 1, which is not valid. Okay, so this is not a valid solution. And here, when we add this, we get the absolute value of 1/2 equal to negative 1/2. Again, that's also not valid. So no solution here. All right, in 2a, we have, once we multiply through, we see that we have a quadratic, 2x squared minus 5x equals 3. So let's put it in standard form, in other words, set to 0, and try to factor. So let's see, here we have 2xx. Sorry, 2xx. And here we have 1 positive, 1 negative. We can only fill in with 3 times 1. So let's see, let's try this. The middle term, minus 6x plus x, is minus 5x. Set to 0, here we have x equals 3. Here we have 2x is equal to minus 1, and x is negative 1/2. All right, in 2b, we are going to factor by grouping. Okay, so let's group together the first 2 terms and the second 2. Pull out a common factor here. We'll pull out x squared. And here pull out minus 9. We have x plus 2x plus 2, so factor that out. And this factors as x plus 3, x minus 3. So we get 3 solutions: x equal negative 2, x equal negative 3, and x equals 3. In 3, we're dividing 2 complex numbers, and so we multiply by the conjugate of the denominator. Okay, here we get 1 plus I times minus I, which is plus 1. And in the numerator, let me just remind you, when we multiply conjugates, here we have something like a plus bi times a minus bi. The result is a squared plus b squared. So here we have 1 squared plus 1 squared, 1 plus 1. Okay, in the numerator we have to FOIL this out. This is 3 times 1. Then we have minus 3i plus 2i, that's minus I. And 2i times minus I is minus 2i squared. And I squared is negative 1. So that's plus 2. So we have 5 minus I over 2. In 4a, let's remember to isolate the radical. So here we have adding 2 to both sides. The radical is isolated. Now square both sides. Whenever we square both sides, we're going to have to check our solution. Let's add 2. And divide by 3. And now let's do our check. Three times 17, we're substituting right into here. 3 times 17 is 51. And here we have square root 49 equals 7. So that's correct. Okay, let's look at B. All right, here we have, we're going to again isolate the radical. Square both sides. Here we're going to FOIL 1 minus x times 1 minus x. So we have 1 minus 2x plus x squared. We get a quadratic. Let's put it in standard form. Subtract x from both sides. And subtract 1. And now factor out the x. And we have x equals 0, x equals 3. And then we'll do our check. First for x equals 0. All right, we're checking x equals 0. Substitute back into the original. And we have the square root of 1 is equal to 1 minus 0. So that's good. Now let's do our check for x equals 3. Okay, so we have the square root of 3 plus 1, that's 4, is equal to 1 minus 3, so this is no. So we have one solution.